Are we on? We're on? All right.
All right.
Hello, Las Vegas. Good afternoon.
And welcome to SEMA 2022.
Collision repair and refinish
Stage.
There we go.
All right, there we go.
Well, my name is Niels Pietjens, and with me here today is Mr. Jeff Poole
Yep.
and Joel Dufkis.
Yep.
And a little bit of introduction on Mr. Poole is that he is the mastermind of our EV hands-on skills and development training.
Now that's almost scary.
It is. And then we have Joel Dufkis, who is responsible for delivery as one of our trainers.
Correct.
So I would like to show the audience and explain to the audience what our hands-on skills development EV training is all about. And it starts for a student at home. Can you fill us in, Jeff?
Absolutely. So as we started looking at developing this training, we started doing a lot of research on all of the different EVs that are out there. And that goes from service information and even me doing some late night digging into patent information. And it was really interesting and kind of fun for me as we put this together to learn about how the different vehicle makers are doing what they're doing, some of the similarities and differences, and give us a really good grounding on, okay, where should somebody start? And whether it's a high voltage, an EV, or whether it's something as simple as a flashlight, it all starts with electrical theory. So you're going to start with some basic electrical theory. You're going to start looking at operation of a basic digital voltometer and things like that, so you understand the principles at work, because the principles at work are just the same no matter what the electrical or electronic application happens to be. And then from there we started to really dive into some of the different battery technologies and vehicle operational information and things like that, and take a look at, okay, somebody starting out just learning about EVs, an introductory course on EVs, the basic operation, and identification and things of that nature. From there, we go into some of the safety considerations for initial vehicle intake and inspection. Whenever that vehicle comes in as a collision damage vehicle, understanding what to be careful of and look out for. There it goes on to some damage analysis topics, digging in a little bit deeper, and then from some component operations, some of the different parts and modules, and how the different components interact and operate. We went from there to take and really breaking down, we made a generic vehicle that could be representative of any electric vehicle out there. And we broke that down into block diagrams of helping folks understand the high voltage system isolation and the safety aspects of the vehicles for the low voltage interlock circuits, and understanding some of the isolation principles and things like that, and also going into some of the bonding and not adhesive bonding principles that go along with that. From there we went into a little bit of the service information, and I'm going to call it electrical testing for shutdown and testing for high voltage isolation, just on a theory level in the online courses. Really to help set that learner up for that live experience where they come in and then they experience that 5-day event where they get to work with that EV training cart and the other props that we've got on hand to work with. So that works out really well for us, and that way hopefully whenever their students get there, they'll have a good experience with the 5-day event.
So as a course developer that you are, I heard two huge challenges. Getting all the information in, educating yourself, what are all the car manufacturers doing, and seeing a generalization so we can have a generalization in our course and still have the overlap and cover everything in our umbrella. The second challenge we have here is at what level is the student at, and how can we make him process this necessary information to go on to the hands-on skills development course. So we developed 8 prereqs. You shared with me, it was 8 prereqs?
I think it's 9 right now.
9 prereqs, where we train the student at home online with this necessary information that they need to grasp. You even build tests in there, correct?
Yep.
So you're probing the students already, hey, what level are you at, and how did you process this information that we fed you to go on to the next level inside that video, inside that online training?
Yep. And so with that, I strongly recommend that somebody that's looking at coming to the 5-day training they do those prereqs at some reasonable point in time before. And what I mean by that is reasonably close to the point in time where you're going to actually attend that class. It doesn't stop you from taking them beforehand. You can take them a year early, and you can always go back in and revisit them. So if it's been a while since you've taken those and you don't have a real good command of the theories behind it, maybe revisit those online courses that are in your library on your MyICAR account.
Yeah, definitely. That's keeping that fresh in your mind and coming in with knowing the information ahead of time is going to help you succeed in that class. If you took them a year ago, you're going to be hard pressed to kind of get through that course. It's made it a little bit harder for you to do.
Unless you work with this every day, I think of it like riding a bicycle. You know, when I was young and rode a bicycle, I could do all the fancy tricks. I can ride a bicycle still, but I'm not doing any fancy tricks.
Yeah, definitely. You need to stay on top of that stuff. Electricity, like you said, as long as you know it, you still know it, but you get a little rusty at it. Same thing with like welding and stuff. You know, I got over there and ran a bead the other day, and it didn't look that great, but I haven't welded in a couple months. But after a couple minutes, I'd be good to go. Same with electricity.
Yep.
So, which one was your most challenging one to work on in the prereqs? Is there something that you said like, wow, Neil, that really kept me up awake at night?
You know, that one's a tough one for me because all of it, there's something in me that
kept you all up.
I just love it.
I know you.
It's one of those things that if it's electrical in nature, from basic Ohm's law and electron theory or whole current theory, whichever one you prescribe to, doesn't matter. It works either way. For me, all of them were just so much fun. I think the most challenging one was where we started really looking at the lithium-ion batteries and some of their tendencies whenever they're not happy, and how they can get a little explosive.
Yes. Well, we shot some videos on that one too, but we didn't release those yet.
Yeah. Yep.
But, well, you know the story in Florida right now with the flooding and stuff like that. So I heard 28 cars lit up in fire caused by a thermal event because ocean water got inside the batteries and upset the batteries a little bit. And then the battery said, you know what, I'll check out and start a fire here.
Yep.
So,
yeah, well, those batteries are, while they're somewhat sealed, they do have vents. They have to breathe, for a vehicle that goes from, I'll say, sea level to the top of the Rockies, and there's an atmospheric pressure change. They've got venting on there designed to allow that battery, the pressures to compensate or equalize. That's the word I'm looking for. And while they're also sealed up to an extent where under normal driving conditions, even if it's raining heavily, they're not going to get water in them. Let's face it, once they go underwater, bad things are going to happen.
Yeah, once you're covered up to the roof in water, salt water, it's going to find its way in there.
And salt water, you put a battery in salt water and it's going to start to discharge. You put all of that energy that's in those batteries in salt water and it gets in there, there's probably a lot of heat being generated. And once you start generating that heat, things start to get really ugly.
But the main objective of our course is collision-related faults.
Yep.
And so when a car was involved in a collision and now it ends up in a collision shop, we would like to have that collision tech to be ready to address this vehicle and this technology, have the right knowledge and the safety procedures, and knowing the protocol so he can apply it for his safety and the shop environment safety.
Absolutely.
And that's what you brought in with your lithium-ion technology and explaining the technology and the potential hazards of it.
Yeah. So as we went through the development, and there were many thought processes that went into this, and the way I approach EVs is I want to be multiple mistakes away from a bad day. I don't want to be one mistake away from a bad day or two. And having done the research on the different vehicles that are out there, the vehicle manufacturers are putting a lot of effort into designing these systems extremely well so that they're very safe under a multitude of different conditions, including collision scenarios.
You have to try really hard to create something bad.
Yeah, but at the same time, in a collision scenario, you don't necessarily know the full extent of what happened to that vehicle. And so that's why we're always taking that overly precautious approach. And that way, even if you do have a bad day, you're protected. You've got your PPE on. until you absolutely 100% know that that vehicle is safe to proceed with operations on, you need to go in with the right protection.
Yeah,
And
collision's at a whole other realm of difficulty to EVs because you don't know where high voltage lines might be run, what might be pinched, what might be cut, what might be touching things that shouldn't be touching. So it's a whole nother level of carefulness needs to be in there. And like you said, I'm always looking 4 steps ahead and making sure that I'm safe so that I'm multiple ways away from something bad happening.
so your initial question to me about which one was the most fun, I answered it in the context of the online classes.
Oh yeah.
Absolutely, the most fun one is the 5-day event.
Okay.
But
We're gonna
building
go
out
into that.
building out the electric training cart and all of that was, I'll say, Mr. Fuchs' inspiration and my perspiration. But a lot of fun.
Coming back to, and I use this phrase, this wisdom from you that we have in our video, the unknown is what gets you killed.
Yep.
Right? And of course it generates a lot of fear, but we need to replace that fear with knowledge.
Yep.
And that's why we set up an 8 modules of prereqs that the student need to follow, need to pass with your multiple choice questions, and then after that they get released and get an invitation to our 5-day hands-on skill development training.
Absolutely.
Now, Joel, coming back to what Jeff has designed in his prereqs, what's your experience as a trainer and communicating with your students the first day, the introduction, knowing their level, probing them, and then starting working with the circuit boards and building simple circuits?
Yeah, when they come in, we talk about the prereqs and how they liked them, and kind of, like you said, probe them and see how they did on them, and their level of understanding, so we can kind of gauge where they're at. And they've all come in with a pretty decent level of knowledge where we can get started and we can get going and be at a little bit higher level than you normally would be if they walked in with no knowledge at all. So we can start hitting a lot of harder topics earlier on than we would be if they had not taken those prereqs. And even myself, I took the prereqs, and I consider myself pretty knowledgeable in that area, but it was a good refresher to make sure I understood what was going on, and some of those things that you might forget, some of that really basic stuff that you've long learned ago, it kind of refreshes you on that. Make sure you keep that in your mind because the basics are always the same.
So what I hear from you is that this adds on tremendous efficiency for the live course itself.
Yeah, it's going to add an
For
efficiency.
every level of technician that is out there that has his hands on a DVOM or knows about electrons and voltage or has no to limited knowledge at all.
Yeah, and even we've had people in our training classes who've never touched a DVOM in their life, and they watched the prereqs, and then they came in. When they come to the class, when they come out, they're like, oh, I know how to use this thing now, and it's incredible.
Well, my experience when I did the training, I had a student and he expressed himself, and he used different terminology, but he said, I dislike a multimeter. And within the next 24 hours, I had him say, I really like this meter.
I think it's a piece of understanding. It's no different than, you're working with a piece of equipment you've never worked with before. You don't understand it. And so it's frustrating, and it gets you mad, and it's like, this is junk, I want to throw it away.
Yes.
Once you understand, and that's the key piece with the test equipment. There's some very specialized test equipment that goes along with the EV realm. But once you understand that piece of equipment, and you understand what it's telling you, the information it's providing to you as you're doing testing, it becomes your friend. And to a certain degree, we're trusting our life to the readings we're taking in some cases, that we then have that 100% confidence that our piece of test equipment's working properly, that we're using it properly, and we're interpreting it properly. And that's the key with any electrical diagnostic, whether it's low voltage or high voltage, is really getting, I don't want to say comfortable with it, but really having mastered the understanding of what that meter is telling you, depending on what scale, what units of measure you have, and things of that nature.
And making sure your leads are in the right spots where they need to be and all that
And
stuff.
your settings.
Yep. And when you get a meter at first, you look at it, there's a whole bunch of, there's a knob with all these things and all this, and if you don't understand it, it's very hard to use. So I understand, and I was in that same training class, and that student went from not knowing anything the next day, he was proficient using that meter, and it was awesome to see.
But the cool thing what a meter does is make the visual, right?
Yep.
I cannot see electrons I don't know how many electrons are running through that orange cable, but by measuring current,
and you
all of
can't
it-
see the potential, the voltage,
exactly.
until you measure it.
So
Yeah.
it gives you a set of Superman eyes.
Yeah.
Right?
Yep.
Superman has some different advantages, but
But-
he can fly too.
But if you get a hold of it and the voltage is high enough, you will feel it.
Yes, yes. So let's talk about feeling, because it's a technical training, a 5-day hands-on training. People really need to commit to come to our CTC building, 60,000 square foot, cut up in 3 pieces, EV lab, ADAS lab, Flex lab, AR, VR technology, state-of-the-art educational center that we have built it to provide the collision industry with the right technical information, right?
Absolutely.
So 5 days of hands-on skill development training. Let's talk us about how your approach was on that and how you developed that course.
So as we started putting that together, that came after we had developed the online courses, and we wanted to then take and, how do we get that student to go from, I want to say, seeing the graphic images and things that we had put in the online courses to now applying some of that and get that real experience. So we looked at having them work with some low voltage circuits, and we've got some electronic, I'll call it building kits that we use, and they're very nice kits. Lucas and Noel.
Nule.
Okay.
You're close.
I don't quite have the right spin on it's a European company, but they put together a very nice training package where we can build different circuits. And we start out with some very simple circuits and doing some measurements so that we understand what our meter's doing, what our different components are doing, and we tried to build circuits that tended to lean towards some EV application of some sort.
Yeah, by the time we're done, we're building circuits that mimic what's going on inside the actual EVs, and then we can use that on the next couple days to reference back to when I say, oh, hey, we're talking about the capacitor discharge circuits. Hey, remember we build a circuit like that? And then they can connect the dots and understand how that stuff works.
Right.
But those boards, we were working with 12 volts, 24 volts. I had a student say, he says, I thought I was coming to a high voltage class, right? So why are we using just 12 volts or 24 volts?
We got to start at a lower level, make sure we're in a safe zone, that we're not in the high voltage range. So then after we train them up and we feel they're proficient enough, then we can release them onto high voltage vehicles.
So you're saying that a 12 volt system has the basic principle operation of a 1200 volt system. It's just a couple of zeros and a little bit more dangerous.
The electrical theory is the same.
There you go.
It's all about scale.
Thank you.
Yeah. Yeah. So if I were to get my hands or lay my arm across a 12 volt battery, current will be flowing, but I won't feel it unless it's a really hot day and I'm sweating a lot. And I might get a little bit of something that'll give me a little bit of a tingle across my arm, and I've done it before in the summertime, where you whack. Oh man, embarrassing situation. But a lot of techs and most of us are comfortable with low voltage because we never feel anything. We never experience a shock. Now
You get
many of us-
comfortable. You get comfortable with the safety aspect.
Right, and that's where we don't want folks to be complacent with high voltage, because whether it's, I want to say 110 volts in your house wiring, or where we're seeing 400 or 800 volts in some of these EVs.
900 now.
That starts to get lethal very quick. And so that's where our approach was, let's get them working with that, with those different circuits we have them build. Then let's have them transition over to the cart that we have, the training cart that actually has a lot of EV components on it, but it's still a low voltage environment. But that allows them to go in and see the different components, because let's face it, on a vehicle where all the wiring's hidden, and well, most of it is anyways, and you don't necessarily see how the different parts are connected, that training cart allows them to see the interconnections.
And depending on what kind of vehicle it is, some front wheel drives do a lot of stuff stacked under the hood.
Yep.
You get to these all-wheel drive dual motor vehicles, and you have modules and wiring all over the place. So it's hard to really get a grasp of where all that stuff's at and how it works. And even doing like a disconnect, trying to check for voltages, trying to disconnect harnesses in the car, it's kind of hard place to get to and stuff like that. So the cart allows us to offer the student to understand the system as a whole, but also be able to do testing very easily.
So we also designed the training cart so that we had the ability to plant bugs, I'll say. introduce an isolation fault, introduce some sort of a grounding bonding fault issue. Pardon my terminology there, because it's not grounding, it's electrical bonding. Essentially, we're able to take and introduce a simulated welded shut contactor type situation. So that way, as they're learning the use of some of the test equipment, and as they get proficient with that, we can then introduce a fault, and they have to go through that decision-making process of, I'm supposed to see 0 volts, why do I see 12 volts or anything other than 0? You know, you have to send up that red flag at that point in time to say, something's not right here, what's wrong?
Yeah, the amount of faults and stuff that you were able to build into that card is incredible, and it's very helpful as an instructor to be able to do that stuff. And I can cater to different levels of my students. So if I have a student that's still kind of learning, they're not quite sure, I can put some easier faults in. But then I have that student that's real high level and they know this stuff in and out. I can really do some difficult faults and really challenge them to figure out what's going on in these vehicles.
So we mentioned the DVOM, but of course, and I made reference to some of the specialized. So maybe tell us a little bit more about some of the specialty testers that they'll get used to or become familiar with.
One of the first ones, one of my favorite ones, is our 2-pole tester. It's a very simple tool, but it makes a ton of sense why we use it on EVs in the situation. Our EVs are dealing with both AC and DC power. In a typical multimeter, you have to switch between AC and DC to figure out both. 2-pole tester, very simple to use. It measures both AC and DC. It doesn't need a battery inside of it. I'm checking, and what I'm using it for is basically saying, do I have power, yes or no? And it's a good no-go, no-go gauge, and I don't have to worry about switching things back and forth and all that kind of stuff. From there, we get to our milliohm tester. So, you know, we're all used to dealing with ohms and stuff like that, and you take a traditional multimeter and you put it across some of these connections we have in the EV, it's going to show 0. Well, there's not 0 ohms there.
Everything has resistance.
Everything's got resistance, so these milliohm meters will allow us to get down to that milliohm level and see what the resistance is, which is very important in our bonding situations because we don't want to become the path of least resistance. We want those bonding cables to become the path of least resistance.
So that's an interesting reference. Path of least resistance, but current always seeks all available paths. So even if there is a path of least resistance and you become another parallel path, that's when the bad things happen.
But they're there to protect us. So
absolutely.
And then we get to our mega ohm meters. So now we're going from real tiny ohms to really large ohms, and that's where we're testing our isolation to make sure that we don't have high voltage positive, high voltage negative touching because it's a floating system.
Right.
And if we have faults in 2 different modules, we're hoping the bonding takes over and blows the fuse and protects us. But you know, in this case, we can kind of figure that out and make sure it's working right.
So our normal DVOMs put a very small current through the circuit at a very low voltage in order to measure ohms.
Yes.
This particular meter puts a very high voltage into that system.
Yeah, we can choose different voltage levels. So typically, most of them nowadays are 500 or 1,000 volts we can induce in there to make our measurements and make sure they're right. And even the milliohm meter is taking, you know, you induce a little bit of current to measure ohms, right? It's all Ohm's law, right? Yes. We all know how that works. But the meters we're using are putting out 1 amp of current to make that measurement very accurate.
And it's really designed just for, I'm going to say, large cables or bonding testing applications, or perhaps the resistance within a large connector.
Yeah.
Right.
Yeah.
Let me give a recap here for the audience and the people at home. So when people come to our hands-on skills development, they have a circuit board, they can build circuits. We teach them how to use these toolings, the DVOM, read current, read voltage, measure resistance, and then we take them to the high voltage simulation card where we have other specialty toolings, 2-pole tester, milliohm meter, and our insulation tester.
We go through all of our PPE needed.
And then they're testing and practicing as a team, feeding on each other, and we keep educating and monitoring them. We're going to run low on time here, but I think we can squeeze
okay.
1 or 2 more extra minutes. But I want to talk to you about how do we verify that when we release these people and we certify them, that they have the right knowledge to bring home in a safe environment for themselves and for the shop. So what did you do there, Jeff?
So at the end of it all, the student does actually have to come back in and demonstrate their proficiency there's a written multiple choice post test, and then there's an actual hands-on performance-based piece of this that they have to come back into that training cart where we may have bugged it in some way or not, and they have to come in, use their test equipment, go through the right steps in order to verify it's shut down. This particular training cart's built so that there's several different ways they can shut down the high voltage, but they have to follow the right steps in the right order and have their PPE on as required, things of that nature, so that whenever we release them, we see that they grasped all the concepts and everything that they needed to on the use of the test equipment. If they're at a point where they don't understand how to use that isolation tester, that's a problem. If they don't know how to use that bonding tester, that milliohm meter, they need to be proficient with that. We give them plenty of time to work with the equipment. And I know since the initial pilot, we've invested in having more equipment on site so that there's plenty of opportunity, and we've built multiple training carts. I think another piece of this training also, though, is that we do have a couple different EVs, actual EVs. We've got a Mach-E and a Nissan Leaf and a Chevy Spark on site that they can gain some familiarity with those as well.
Yeah, those are nice because we can go through the different shutdown procedures in those vehicles. So the Spark and the Leaf are very similar, using a high voltage disconnect, where the Mustang Mach-E is using a low voltage disconnect, which is what a lot of more manufacturers are starting to move towards. So we can give them experience in both realms so they can understand how to do both. And our carts are set up to be able to offer both of those as well. So we're going to make sure that they understand both sides of that and really have them go through that cart. And once I know that they have that understanding, then we can go to those cars and really get them hands-on that stuff where there is live voltage and there are consequences. So, make sure they're safe and monitor them and that everything's done correctly.
Well, I've attended many trainings and seminars, and I got a lot of certificates of attendance. But this certificate, once you pass this theoretical knowledge, right, they need to prove in a 1 hour written test that they have the basic fundamental knowledge in writing and can reproduce that, and then they have to do a physical reproduction of their knowledge. And we put them on the back foot and really test them and bug them like you put your bugs in there, really to probe the knowledge that if you get in these live working, potentially dangerous situations, that you know to work your way out of it and create a safe environment for yourself and do the right measurements.
I think the key in my mind is, helping folks understand where do I draw the line for myself? And I think every technician out there has to be honest with themselves on, am I confident that I can move forward and there is zero chance of injury or a problem with the vehicle that I make worse? There comes a point in time where you really have to be honest with yourself as you're doing this. When we developed this, we were thinking about all of the different EVs coming out and the opportunity we have as an organization to provide a good solid foundation. I get where a lot of OEs have very specific training on their different models and different requirements, but this will provide a very solid foundation for a multitude of different vehicle manufacturers that are out there.
Yeah, because in an inclusion shop, you never know what's going to roll through the doors or off that tow truck the next day, and you might run across multiple manufacturers, and we're able to teach to the multitude of different processes in there.
All right. Anything to add from your side, Joel?
Not much. I mean, we love to see people come out, take this class, get trained up. The 5-day class is definitely a challenge. It's going to challenge you. It's going to be a hard class, but you're going to take home a ton with it. And it's a very hands-on intensive class. There's not a lot of sitting there lecturing at you and listening to stuff. You're doing a lot of hands-on work. Almost, I'd say, 85 to 90% of the time.
So it was designed for the instructor to observe and coach, and not just dictate what they do.
This is not a monkey see, monkey do training. We really want the people to walk home, comprehend the material, and be able to apply their knowledge back in their shop environment.
Absolutely.
That was your objective, and I think you did an awesome job, Jeff.
Thank you.
Thank you.
Definitely.
And with that, we're out of time.
Thank you very much.
Thanks, everyone.
Checking
you.
out in Vegas.